The star, Earth or Sun relative to Galactic Center. The stars is mentioned in Quran chapter 53. In fact, chapter 53 of the Quran is named and Najm the star. The distance from the Galactic Center to the Sun, and Earth, of course, is 8, which is 5 plus 3 kiloparsecs, passing through the Scutum Arm at approximately 5 kiloparsecs, satisfying the 5:3 ratio. Among the 58 bright stars historically used for celestial navigation, Deneb is the farthest, shining from a distance of approximately 0.8 kiloparsecs. Yet its immense luminosity makes it a consistent and reliable guide for sailors by the stars when they fade away. Your fellow man Muhammad, peace be upon him, is neither misguided nor astray. Nor does he speak of his own whims, it is only a revelation sent down to him. And Najm 53 verse 1-4. While celestial navigation uses a standard set of 58 bright stars, their true distances from Earth vary dramatically. The vast majority of these navigational aids are located within 0.1 kiloparsecs, approximately 326 light-years, making them our relatively close galactic neighbors. This group includes some of the most famous stars in the night sky, such as Sirius, Procyon, Vega, and Polaris, the North Star. These stars appear exceptionally bright in our sky not only because of their intrinsic luminosity but also because of their relative proximity, ensuring they are consistently visible and reliable reference points for navigators on Earth's surface. Moving beyond our immediate cosmic neighborhood, a smaller but significant number of navigational stars are found at greater distances, ranging from 1/10 to 1/2 kiloparsecs and beyond. These stars are not chosen for their nearness but for their immense intrinsic brightness. They are typically supergiants or hypergiants, which are hundreds or thousands of times more luminous than our Sun. This incredible power allows them to be seen across vast distances, appearing as bright beacons in our night sky. Key examples from this group include Betelgeuse, Rigel, and Canopus, all of which are crucial for navigation despite their considerable distance from Earth. Ultimately, the reason navigators use stars with such a wide range of distances is to create a complete and reliable celestial grid. Stars like the exceptionally distant Deneb, located at around 0.8 kiloparsecs, approximately 2,600 light-years, serve as a testament to the power of stellar luminosity. This vast array of stars, from the very close to the exceptionally far, provides a reliable celestial map for determining one's location anywhere on Earth. For context, our entire solar system, including the Sun, is located about approximately 8.12 plus or minus 0.031 kiloparsecs from the supermassive black hole at the center of the Milky Way galaxy. This highlights the immense scale of our galaxy and shows that all the stars used for navigation are, in the grand scheme of things, still a relatively small part of our local galactic arm. Based on an image from an paper, the distance from the galactic center to the Sun, and Earth, of course, is 8 kiloparsecs, passing through the Scutum Arm at approximately 5 kiloparsecs, satisfying the 5:3 ratio. Standard unit for Sun-Earth distance is 1 astronomical unit, and 1 parsec is 206,265.806 astronomical units. Northern and Southern stars. The stars is mentioned in Quran chapter 53. In fact, chapter 53 of the Quran is named and Najm the star. Sailors used a total of 58 stars for navigation, including 26 northern stars, which have a declination of 0 or greater, with a combined distance from Earth of 6,850 to light-years, and 32 southern stars at a total of 11,334 light-years. The ratio of the distance of southern stars to northern stars is approximately 1 to 0.60455 to 67337 to 155 or 5 to 3.0 to 276. 336686077, approximately a 5:3 ratio. Northern stars, which have a declination 0 or greater, 26 stars, total distance 6,850 to light-years. The provided distances for each star are measured in light-years, a unit of length used to express astronomical distances equal to the distance light travels in 1 year. The distances are as follows: Polaris at 447 with a Gaia parallax of 7.2928 plus or minus 0.0348 mas. Alpheratz at 97, Aldebaran at 65.2, Alderamin at 49.0, Alioth at 82.5, Alkaid at 104, Altair at 16.7, Arcturus at 36.7, Bellatrix at 251. Betelgeuse at 548, a non-Gaia measurement with high uncertainty. Capella at 42.8, Deneb at 2618, a Gaia geometric measurement. Denebola at 35.9, Dub at 124. Ilnath at 134, Enif at 691, Hamal at 65.9, Kakab at 126, Markab at 140, Menker at 220, Murphic at 593, Pollux at 33.8, Procyon at 11.5, Regulus at 79.3, Skeeter at 228, and Vega at 25.0. Southern stars, which have a declination below 0, 32 stars, total distance 11,334 light-years. Akamara at 161, Akerner at 139, Acrix at 322, Adhara at 430, Alnair at 103, Alnilam at 1,342, Anka at 85.0, Antares at 553, Atria at 415, Aviar at 630, Canopus at 310, Difta at 96.1, Fomalhaut at 25.1, Gacrix at 88.7, Gina at 165, Hatter at 392, Cos Australis at 143, Menkent at 61.0, Maya Placidus at 111, Wurzim at 500, Nunki at 224, Peacock at 183, Rigel at 863, Rigel Centaurus at 4.37, Sabak at 84.2, Safe at 650, Shala at 571, Sirius at 8.60, Spica at 250, Suhail at 545, Wezan at 1802, and Subin el Janubi at 77.0. Gaia Dr. 3 sources. Geometric distances from Baylor Jones et al., 2021. Bright stars like Betelgeuse and Rigel have high parallax errors. Distances use consensus values, Deneb, Alnilam, and Wezan use Gaia geometric distances, which are an improvement over raw parallax measurements. Values may differ slightly from older catalogs, such as Hipparcos, the star of Syrah, and he alone is the Lord of Sirius. And Najm 53 verse 49. In the pre-Islamic Arab astronomical tradition, the star Syrah, known as Sirius, was not just a point of light, but an object of worship that was highly exalted, especially by the Kuza tribe. They were mesmerized by its matchless brilliance in the night sky. In the pre-Islamic Arab oral tradition immortalized in classical astronomical books such as Suwar al-Kawakib by as-Sufi and al-Anwa by Ibn Qutayba, the stars Syrah al-Abr, known as Sirius or Syrah al-Yamaniya, and Syrah al-Gumesa, known as Procyon or Syrah Asisaymiya, were told as to sisters who tried to catch up with their brother, Suhail or Canopus, who fled to the south. The brave Sirius succeeded in crossing the celestial river, the Milky Way galaxy, so she was nicknamed Syrah al-Abr, meaning the passer, while Procyon, who was left behind on the northern bank, wept bitterly until her eyes dimmed, which earned her the nickname al-Gumesa. Based on precise modern astronomical data obtained through the GAA satellite mission, it is now known with high accuracy that the two sister stars in celestial mythology, namely Syrah, known as Sirius, and al-Gumesa, known as Procyon, are relatively close neighbors to our solar system. Specifically, Sirius is at a distance of 8.609 light-years, while her sister, Procyon, is located slightly further away at a distance of 11.46 light-years from Earth. Mathematically, the ratio between the distance of the passer, Sirius, divided by the distance of her sister who was left behind, Procyon, produces a value of 0.75122, which is the sine value of an angle of 48.69 degrees. If the result of the angle is rounded to the nearest unit, the number 49 appears. This number represents a unique spatial relationship between the two stars mentioned as the star of Syrah in the Al-Quran, Surah An-Najm. Verse 49. Fun math. The text says that An-Najm contains 1,422 letters. The distance from the Sun, and Earth, of course, to the Galactic Center is 8.122 parsecs, where 1 parsec equals 206,264.806 astronomical units. The sum of the digits from these two values, 8,122 and 206,264,806, when added in a specific way, equals to 1,422, 206 plus 626 plus 480 plus 81 plus 22 plus 16